Yes, sir.
Yeah. So in the previous classes, class, basically we have completed up to molality, I think, right?
Yes, sir.
Okay. So I'm going to give you a question again. Then we will move to the next part. Question is basically 10% weight by weight, NaOH, in aqueous solution. Calculate molality. And after this, the last concentration, the concentration term I'm going to take is normality. And this chapter will be completed. Let me know if you have any doubt in this. Okay, there will be some more question on molarity. I will give you only the uh, formation of sentence will be different, but it is very easy if you will get it.
So 25 by 9 M,
Very good. What you just did is 10% weight by weight, 10 gram NaOH in
100-gram solution.
solution. Very good. So now you are going to calculate molality, number of moles of solid, 10 upon 40 upon mass of solvent, that will be 90, right?
Yes, sir. 90 upon 1000.
That will be equal to 10
90
by
upon
40.
1000.
Yeah, 1000 in kg. Thank you. And it will be 1000 divided by 90. And after solving it, you will get your answer 100 by 25 times, it will 25 by 9, right?
Yes, sir.
Okay. So now another question I'm going to give. It just clicked in my mind that calculate mass of NaOH of semimolar solution having 500 centimeter cube of solution. Just read the question and omit whatever it is, whatever is given in the question. Let me know if you can do it or not. It's very easy.
Then what is semimolar?
Semimolar, semicircle. Do you know what is semicircle?
Half circle.
Half circle. Molar means molarity. Semimolar means half molarity. Are you getting my point?
No, sir. So just we have to divide whatever molarity we get by 2. Like
No,
that.
not like that. If I'm telling you that semicircle, that means half circle. Are you getting my point? Semicircle means you have a
Yes.
full circle which you have divided into two parts, half circle. So
Yes, sir.
semimolar means half molar. This is indirectly given the value of molarity, that means half molarity. That means half moles per liter. Are you getting got it?
Okay. Yes, sir.
This is the term sometimes it uses. It can be given that semi-molar, semi-normal. This is very important.
So they all mean the same. They all refer to
Yes.
mole.
No. If I'm telling you that semi-molar, that means half molarity. If I will tell you that semi-molal, that means it is given half m molality, moles per kg. If it is given semi-normal, that means normality, we will study about it, half n gram equivalent per liter.
Okay, sir.
Like if it is given that bimolar, bi means 2, that means 2 molarity. Bimolal, that means 2 moles per kg, that means m. Binormal, that means 2 normality is given. Got it?
Yes, sir.
If it is given, this is important, centimolar, centimolar, that means 1 by 100 m. If it is given centimolal, that means 1 by 100 small m. This is just a term we use. Semi-normal, that means 1 by 100 n normal. If we are talking about desi normal, that means 1 by 10 m. So these are some terms you are going to use or you have to remember while solving the numericals. Please do this question.
Sir, I can't do this.
You can't do this. See. So are you done with this? Please write all this.
Done, sir.
Okay. So see, calculate the mass of NaOH semi-molar solution of 500 centimeter cube. Semi-molar solution of 500 centimeter cube. And we need to calculate mass of sodium hydroxide, that is NaOH. Now see, semi-molar, that means molarity is given as half. Yes or no?
Yes, sir.
This is volume, that is given 500 centimeter cube, and we need to calculate mass of NaOH. Now see, we have a formula, molarity is equal to number of moles of solute upon volume of solution in liter. Molarity is given as half, and molarity is given as half, and number of moles of solute we need to calculate first, upon volume of solution is 500 centimeter cube, which means divided by 1000. Yes or no?
Yes, sir. Yes.
So this 0 will be cancelled and 1 by 2. This 2 will come here, and number of moles of solute will be equal to, 2 into number of moles of solute will be equal to 1 by 2. So number number of moles of solute will be equal to 1 by 4 moles or not?
Yes, sir.
Tell me. So this is the number of moles, but we need to calculate mass of. So number of moles is equal to given mass upon molar mass. Number of moles is 1 by 4. Given mass is m, and molar mass of NaOH is 40. So m will be equal to 40 by 4. That means 10 gram.
Okay, sir.
So please write it. Let me know when you are done with this.
Done, sir.
Very good. So I'm just going to give you another question. Calculate mass of CaCO3 of decimolar solution. Having 250 centimeter cube of solids. Please do this question.
So it's 2.5 moles,
2.5 moles you have calculated, but what
2.5
is,
grams.
let me check. So basically, molarity will be equal to number of moles of CaCO3 that will be solved upon volume of solution, that is 250 upon 1000. That will be approximately equal to 1 by 4. It will multiply in this, and what is the
1
molarity?
by
That
10.
is 1 by
1 by
10
10.
will be equal to 4 number of moles of CaCO3. Again, number of moles of CaCO3, you will get it by 1 by 40, right? Now, number of moles given mass upon molar mass, that is equal to 1 by 40. Given mass is, you need to calculate molar mass of CaCO3 100 will be equal to 1 by 40. Now 0 will be cancelled by 0 and ME will be equal to 10 by 4. That means 2.5. Very good. Are you done with this?
Yes, sir.
Now see, I'm going to introduce a new uh, concentration term, the last concentration term, normality. See, before starting normality, we have to know about two other terms. The first term is gram equivalent or number of gram equivalent, like moles and number of moles. So gram equivalent, and before this, before starting this, we have to know about this, and before knowing about gram equivalent, we have to know about equivalent mass, equivalent weight or equivalent mass, you can call it. So first of all, I am going to introduce equivalent weight, and equivalent mass will be equal to molar mass upon X. You know how to calculate molar mass? Or no, do you know how to calculate molar mass? Yes.
Yes, sir. Yes.
Now this X is valency factor or N factor. Valence factor or N factor. We call it valence factor or N factor. So to calculate equivalent mass, it's easy to calculate molar mass by the, you can see what is the compound, what is the formula of compound, and you can easily calculate molar mass. But how we are going to calculate valence factor, that depends. Okay, so I'm going to introduce equivalent mass, just write it. Then I'm going to explain how you are going to calculate X, that is valence factor, valency factor.
Done.
Done. See, we have X. So basically, we are going to take three cases of valency factor X. So first case is if the compound is acid, then how we are going to calculate valence factor X. And if the compound is base, then how we are going to calculate. And if the compound is salt, then how we are going to calculate X. Now see, acid, basically for acid, X is equal to number of H plus given. That means, can you recognize whether it is acid or not? Whether a compound is acid or not?
Yes, sir.
So, can you tell me how many H plus will be given by HCl? How many H plus will give HCl? Only one?
1 H plus ion.
Only one H plus ion? That means X of HCl, valence factor of HCl will be 1. Okay? Okay or no? So,
Yes, sir.
if you are going to calculate equivalent weight of HCl, that will be equal to molar mass of HCl upon X, that will be equal to 1. Can you tell me how many H plus is given by H2SO4? How many H plus can H2SO4
2.
give?
2.
2. 2 H plus it will give. So equivalent weight of H2SO4, equivalent weight of H2SO4 will be equal to molar mass of H2SO4, that is 98, divided by 2. X has a value, X will have a value 2 because it will give 2H plus. So 49 equivalent mass. The equivalent mass of H2SO4 will be 49. Are you getting my point? So X for
Yes.
acid will be equal to the number of H plus given by acid. Okay.
Yes, sir.
Now, for base, it is also easy. X will be equal to number of OH minus given. Number of OH minus given. How many it can give? How many OH minus given by the base? Now see, if it is NaOH, how many OH minus it will give? Only one. So equivalent X will be equal to 1. And if you are going to calculate equivalent weight, that will be equal to whatever is the molar mass upon X, that means 1. If you have MgOH whole twice, how many OH minus it can give? How many OH minus it can give? 2 OH minus. That means X for MgOH whole twice will be equal to 2, and equivalent weight, if you are going to take equivalent weight, that will be molar mass of MgOH whole twice upon 2. Can you tell me the value of X for ALOH whole thrice? What will be the value of X for ALOH whole thrice? Or now?
Which are solving.
Okay.
So 26.
I just asked you the value of X. What is the value of X for ALOH?
X is 3.
3. That's good. Now you can calculate whatever is the number of
27 plus
molecular
48 plus 3 is 78. This is the molar mass is 78.
Wait a minute. 27 plus 48 plus 3, right?
Yes, sir.
3 plus 8, 11, 11 plus 7, 18. 4 plus 2, 6 and 7. 78 divided by 3. So it will be 3 to
26.
the 6. Yeah. Very good. So here we are going to concentrate only on how to calculate number of X. Now, what is the value of X? Now for salt, X will be equal to, since salt is what? It is prepared by generally neutralization reaction, acid plus base.
Yes, sir.
So see, X is equal to, basically for salt, X is equal to either you can take total positive charge, or you can take total negative charge with magnitude, not with don't take it with sign. Okay, is that clear?
Yes, sir.
Now see, NaCl. Now see, if you are going to dissociate it, it will be converted into Na plus Cl minus. So what is the value of X? X will be equal to 1. Okay, and if you have Na2SO4, Na2SO4, so if you are going to dissociate it, it is a salt, it will be 2 Na plus, balance, you have to balance first, and SO4 minus 2. So X will be here, will be 2. Why? Na plus is plus 1, but 2 multiplied into plus 1, that will be 2. Either you can take plus 2 or minus 2, but only with we deal with magnitude, not with charge. Okay,
So, sir, we
in
multiply
salt,
them. Positive
see,
and negative, we multiply.
no, see, Na plus, how many charge on it?
So 1.
What is the charge? 1. If I am talking you 2 Na plus, what is the charge on this? Total
So
charge
2.
2. So whether you can take positive charge or negative charge, both will be equal.
No, sir, I'm not.
Both. Yeah. Speak up. Arnav, what do you want to say?
Sir, can you hear me now?
Yes, now I can hear you.
We have two Na plus and we have one SO4 minus 2, right?
Yeah, yeah.
So, sir, we multiply the charges like 2 into 1, or it's like, how do we do it?
See. Uh,
How did you get 2?
Total positive charge. Two, I got it. Like whether you can take negative charge just separately, think separately. What is the
Yes,
negative charge? What is the
1
negative charge? Minus 2.
or minus 2.
Negative charge, minus 2.
Yes, sir.
SO4 minus 2. What is
Yes,
the
yes.
positive charge?
2.
At 1 Na plus 1. So if you are going to multiply it by 2, total charge on the positive will be plus 2. See, now in a salt, there will be no charge because it is a neutralization reaction. Okay.
Yes, sir.
So whether you will take positive charge or negative charge, it must be equal and
Yes,
it
sir.
must be balanced. Now, is that clear?
So, sir, if it's unbalanced, then we have to balance it first.
Yes, yes. If you are going to write it like I'm going to take Na2SO4, and if you just do it like this, wait a minute. If you are going to just write this Na plus SO4 minus 2, is it balanced?
No, sir.
No, it is not balanced because only so we are going to multiply it. Now it is balanced. Charge by charge and by atom both. So if you are going to take negative charge, you can take. If you are going to take positive charge, you can take. But whole charge. What is the whole charge on the negative? Minus 2. What is the whole charge on the positive? Plus 2. There will be, so if you are going to add positive and negative, it will be 0 because on the left hand side there is no charge.
Yes, sir.
Okay. So please write it.
So, sir, in all cases, will they be same? Like in NaCl, both sides had one charge, positive and negative. Na2SO4 had both sides, positive and negative, two charge.
Yeah,
Like,
yeah, there
it
will
will
be
be always
positive
same,
on.
or it can be different. Like minus can some negative charge can sometimes be greater, positive charge can
Yeah,
sometimes be
yeah,
greater.
that depends upon the nature of the compound. Like, see, chlorine will have negative charge minus 1, SO4
Yes,
minus 2, sulfate. On sulfate, there is negative 2, minus 2. If it is, just suppose NaOH, on NaOH, what we get? Minus 1. That depends upon the compound.
sir, how will we do for NaOH? Like, how will you find X for NaOH? That's a
See,
basic.
that's a base. So, I just wanted to explain that there will be different charge for different compound. Okay. See, if you are going to take carbonate, Na2CO3, I will just take more example, just write it.
Okay, sir.
Let me know when you are done with this, then I will give you more examples or questions.
Yes, sir, 1 minute. Done, sir.
Very good. Now see, I will just give molar mass, you can easily calculate. So calculate the value of X. Value of X for following. Okay. You need to calculate only X.
Okay, sir.
HNO3, CaCO3, BaOH whole twice, NaHCO3, Na2CO3, Just calculate.
Done, sir.
What's your answer for HNO3? Value of
Sir,
X?
A is 1, X is 1,
Okay. Then
X is 2.
wait a minute.
Okay.
This is X. Okay. One, two, then
2,
two. Then
2,
very good.
2,
Then
and 2.
very good. Now going to ask you some more questions. FG. H3PO4. H. H3PO3. Right. H3PO4. Please do this. Let me know when you are done with this. Wait.
Sir, I got the first two. I didn't get the third one. H3PO2.
Okay, okay, no problem. Uh, Tell me the value of X for H3PO4.
Sir, 3,
Then,
3.
then,
Sir, I don't know that.
okay, this is wrong. The first, second one. See, these are all oxyacids of phosphorus. Oxyacids of phosphorus. What is oxyacids? So basically, what is oxyacids is there will be non-metal, hydrogen plus oxygen. So you can see hydrogen, oxygen, and whatever is the non-metal, that is called oxyacids, and whatever is the non-metal, that is oxyacids of that non-metal. Are you getting my point? Like if I'm going
Yes,
to take you H2SO4, that means oxyacids of sulfur it is. Okay.
yes, sir.
Now see, these are a structure we will go by a structure. This will have X is equal to 2. I'm just telling you the answer, and this will have X is equal to 1. Now see, if you will go by a structure, you will understand it, and it's very easy. The structure is like this, and here the structure will be like this, and you will learn about how to draw the structure of the compound in chemical bonding 4th chapter in this class 11th, and the structure of this will be like this. Now, do you know electronegativity? You'll learn about it all of this
What?
term in this electronegativity.
Yes, sir.
So electronegativity is the property of any element which withdraw the bonded electron. The bonded electron, the bond. You see, oxygen is the second most electronegative element. So hydrogen is very less electronegative than oxygen. That's why oxygen will attract electron from hydrogen, and it will have delta negative, delta positive charge. It will have delta negative, delta positive, delta negative, delta positive. Whenever you are seeing delta negative, delta positive, that means the bond is polar, and if you are going to dip this in water, it will be easily breakable. And if it will breakable, that means it will give 3H plus. That's why X is equal to 3. Are you getting my point?
Yes, sir.
Now see, delta negative, delta positive, delta negative, delta positive. So these bonds are easily breakable, but between phosphorus and hydrogen, the electronegativity difference of phosphorus and hydrogen is not that much. Basically, these bonds which are breakable are polar in nature, and this is not much polar that it will be breakable. So it will give only 2H plus. That's why it will give X is equal to 2. In the same way, this bond will be easily breakable due to polarity of this bond, and it will give only 1H plus. That's why X is equal to 1. And these bonds will not be broken because the bond is not that much polar. Is that clear?
Yes, sir.
Okay, so please
Sir,
write
but
it.
in this case, we had H3, and H3. So couldn't we just take them all in acids and write
No, no.
X3?
So see, what is X for an acid? What is X? Number of H plus given by the compound. Yes
Yes,
or
sir.
no? So if this acid is giving only 3H plus, that's why X is equal to 3. And if this acid is giving only 2H plus, so what was the definition for acid of X? X is equal to number of H plus given by acid.
Yes,
So
sir.
if this acid is giving only 2H plus, then why you are going to tell 3? Third
Okay.
hydrogen will not be
Yes, sir.
Dissociated.
Yes, sir.
Okay, just write it.
Done, sir.
Yeah. So this is basically for equivalent mass. Now you can calculate easily equivalent mass because molar mass you know how to calculate, and the value of X you can easily calculate now. Yes or no?
Yes, sir.
Now the second term, gram equivalent. See, gram equivalent has a formula like number of moles. This is given mass upon equivalent mass. Given mass will be given in the question, and equivalent mass you can easily calculate by looking on the compound whether it is acid, base, or salts. Yes or no?
Yes, sir.
So basically, I'm going to give you a question. 4.9 gram of H2SO4. Find gram equivalent. Find gram equivalent.
So can you do this one?
Yes, why not? See, we need to calculate gram equivalent. Gram equivalent is this formula. So gram equivalent will be equal to given mass, that is 4.9, and equivalent mass. Equivalent mass, can't you calculate equivalent mass of H2SO4? Equivalent mass is equal to molar mass upon X. What is the molar mass of H2SO4? 98. And what will be the value of X for H2SO4? Tell
Two.
me. 2.
Two.
So it will be 49. So just put the value 49 and remove this decimal. So you will get 0.1 gram equivalent. Isn't it easy?
Yes, sir.
Please write it.
Done, sir.
Noted. 10% weight by weight. CaCO3. Calculate gram equivalent.
So 0.2 gram equivalent.
0.2 gram equivalent. What you just did is gram equivalent given was 10 upon 50.
50.
So
So
equal
1 by
to
0.2.
0.2. Very good. Now we are going to introduce. I am going to introduce another the last concentration term, normality. And normality is denoted by n, and I'm going to define it. What is normality? So this is basically number of gram equivalent of solute per unit volume of per unit volume of solution in liter. Molarity and normality has only one difference, that is, in normality we talk about gram equivalent, but in molarity we talk about mole. Yes or no? So from here we can make a formula: number of gram equivalent of solute upon volume of solution in liter. And you can easily calculate number of gram equivalent. Yes or no?
Yes, sir.
Okay. Please let me know when you are done with this.
That's
Very good. So I'm going to give you a question. $490 of H2SO4 present in 500 centimeter cube of solution. Calculate normality. Are you done with this?
1 minute, sir. Sir, 20N?
Just let me check it. So we need to calculate normality, and there is number of gram equivalent upon volume of solution in liter. So first of all, for number of gram equivalent, we have formula given mass upon equivalent mass. Given mass is 490 and equivalent mass. What is the equivalent mass of H2SO4?
98.
Equivalent mass.
Oh, sorry, equivalent mass, sir. It's 1 minute, sir. Equivalent mass. Sir, 49.
14. This is 49. So it is 10. 10 number of gram equivalent. So I'm going to put it here 10 upon volume of solution in liters. So 500 divided by 1000. Yes, your answer is very correct. 20 gram per 20 gram equivalent per liter, or we can call it 20 N. Okay.
Okay, sir.
So here our chapters are is covered, completed the first chapter only. Okay. See you in the next class, and we will have test or objective test for this half an hour next class. Okay.
Okay, sir.
Okay. Thank you.